My name is Wendy Olsen. I work at the University of Manchester as a senior lecturer in socioeconomic research. I'm going to talk about assessment when we use quantitative data in the social science classrooms. I want to focus on some particular tweaking that we do to the assessment methods for social science classrooms where quantitative data is embedded in the teaching. I don't refer here to social statistics classrooms, but to sociology and politics, criminology, or even business studies, where traditionally there's been a shortage of quantitative methods in those classrooms. It's seen as a specialized area, but if we embed it into the basic teaching of the substantive content of that discipline, then more students will be exposed to quantitative data. So the tweaking that I'm going to refer to is to have explicit learning outcomes that are nested, and we have an image here to show how they would be nested from the very abstract ones for a course unit and right down into the assessment items, say an exam or an essay, and then down further going into the detailed list of concrete skills that students have acquired through their course of study. These learning outcomes can be listed and integrated throughout the different module or course units that comprise a course or a degree program. So obviously, if we listed all of the learning outcomes, it would be a very extensive list. But it's necessary to have that in your head as a teacher, and sometimes even to expose those desired learning outcomes to students. There's nothing wrong with saying, for this activity, the learning outcomes are A and B, or ABC, and actually show them what you expect them to achieve. So I'm going to continue now and look at what the learning outcomes would be at Year 1, Year 2, and Year 3. But I am thinking specifically of sociology and politics, where we might have some quantitative methods taught in a specialized way, but what we really want to encourage is using a small amount of quantitative data and methods right across other subject modules. So for example, in the study of spirituality in sociology or the study of ethnicity, you might want to have data about attitudes. The learning outcomes that we would mention in Year 1 would really refer to critical approaches to using the data. Being critical of the data has several steps, which I can list as learning outcomes. The way you phrase your learning outcomes is usually as the student will be able to XYZ. So the student would be able to criticize how a concept has been measured in a survey, and the student would be able to be critical of the harmonization of the wording of a survey. This harmonization has 2 or 3 different aspects. Internal harmonization is whether the survey questions were appropriate for all the minority groups within a population. And external harmonization would be making sure that it was capable of being applied in different countries. So there's a lot of translation and back translation that usually goes on in the international surveys. So returning directly to the concept of measurement, we have a learning outcome about the levels of measurement. Students should be aware of the 3 levels of measurement: categorical variables, ordinal, and continuous. I turn now to the question of representativeness. Students should be aware of how representative a given sample is, and they should be aware of the need for representativeness in some kinds of survey research. Of course, if they're doing qualitative interviews, there isn't a need for that group of people to be representative. It would be too costly, and it would actually overturn the basic aim of qualitative research. So there's a sophistication to how the student would approach representativeness of a sample. And finally, in Year 1, the student should be able to interpret graphs and charts. This is harder than it seems because they may not have a background with much mathematics training, but interpreting a table of numbers and developing row percentages and column percentages has proved to be difficult for some students. So the learning outcome would be being able to interpret a table in terms of percentages, and students will need to practice this skill in order to achieve it. Finally, in Year 1, most students should acquire the ability to interpret a chi-squared statistic. It's a very simple statistic, but surprisingly hard to teach. And instead of relegating this to a boring quantitative methods course, or perhaps having it only mentioned in that course, we can actually reiterate the use of the chi-squared in the substantive courses. To set up the learning outcomes for Years 2 and 3, obviously the students will need to build on what they've learned in Year 1. And the word for this building upward of skills is scaffolding. Scaffolding is widely used in the teaching of teachers. So you learn about pedagogy and you learn about how you scaffold upward to get the building blocks of your skill as a student. So I have an image here that shows scaffolding, where in year 1 or throughout the 3 years you would learn to be a critical reader of the data, critiquing concepts and measurement and the way that things in the world have been conceptualized. But in year 2 and year 3, the students should also begin to make tables and make graphs themselves. So they might use online data in order to have a resource for making those tables and graphs. And in year 3, if they do a dissertation, they may actually use microdata, which would involve the use of SPSS. And they will have to have support in order to use SPSS and even to use Excel. Many students and even staff would feel that they need a little bit of training. But the idea of scaffolding is that you're getting into more advanced activities and you're working more independently in the 2nd and 3rd years of the program. So the learning outcomes in year 2, for example, might involve working out Pearson's correlation, the Pearson's R-squared, and interpreting that as a measure of correlation. Another learning outcome is that they should be able to distinguish a correlation from an association. We've been holding workshops and finding that that's hard for all of us. The association is where 2 variables are categorical, and the correlation is used, that is the Pearson's R-squared, would be used if the 2 variables are both continuous. So students by the end of year 2 should be able to look at a scattergram and interpret it in terms of an R-squared. They might have an idea of the line of best fit or a simple regression, if possible. That then implies another learning outcome, being aware of causality in the world and how it gets represented in quantitative data and in diagrams. It's not necessarily the case that a high R-squared would imply causality. So the learning outcome is to be cautious about the interpretation of data in terms of causality. Finally, in year 3, the students can be making an in-depth comparison of the use of different methods to approach the same question. So applying mixed methods in their dissertation or in an essay or exam context would be ideal. I'm sure you're now wondering about how to grade the merit and distinction levels of performance, so I'll turn to that now. For achieving a merit level, even at year 1, the student needs to be able to show that they can analyze things in their own right, from their own point of view. This analysis might be to apply theory to some data, or to run a test using data to test a theory. But to get a merit or distinction, they also need to critique the operationalization. Operationalization means how the variables have been constructed using concepts that are relevant to some theory or that were seen in the questionnaire. And so it means to make operational the concepts that are in that theory. But unfortunately, you often get the questionnaire that doesn't have the concepts in the theory and has some other wording. And so being critical is absolutely essential in order to do well. Finally, the student doing a merit level of performance needs to be aware of generality. How strong is their ability to make a generalization from those data? That might even lead to making an inference, which would be an explicit statement. Based on this sample, we can infer to this population. We expect that in sociology and politics or criminology classrooms, the inference stage might be reached at year 2 and honed in year 3. So you can see this merit level moving slightly above the descriptive work of the pass student. Finally, I'll turn to the distinction level. Even in year 1, this distinction student should be doing all the things that were learning outcomes for merit and pass, and they should also be original. How can they be original? It's up to them. They can show their creativity. And this is why we don't want to have too many multiple choice tests or things that require rote learning. At university, we expect students to use their own mental resources to develop their own answers to each question. So they can show creativity or be innovative in the way they use data. And in the year 3 dissertation in particular, we would expect some students to be getting a distinction because using the data in itself is an independent act of scientific thinking. So students who do the dissertation successfully with an excellent background and theoretical underpinning and some kind of nice write-up will probably do very well. So we would want to be explicit about that and encourage students to be original, but also to be scientific. Or if you don't like the word scientific, it may be just as good to use the word warranted. This is a word that's in the critical thinking literature, and critical thinking has GCSEs and A-levels attached to it. A warranted argument is one which can be justified using some underpinning arguments. And a warranted argument with evidence is a really good scientific argument, in my view. So a good learning outcome for a distinction at year 3 would be to make warranted arguments, making critical use of available evidence. My last point is about mixed methods, that the students should be able to use both qualitative and quantitative methods. And when we say mixed methods, we often mean both. So I've talked here about the learning outcomes for quantitative methods and quantitative data, but there are others for the use of qualitative empirical data as well. Well, good luck with your teaching.